and welcome to the 9th episode of Simply Electronics Basics. Before we get started, I'd just like to mention all of my videos consisting of these virtual circuits are now interactive. So if you take a look in the description of every video that I have uploaded where I use every circuit, and as long as you're in Google Chrome, you'll be able to open that circuit and perhaps get a better understanding of how things work by changing it and adapting it yourself. So in this video, we're going to talk about constant current sources, and on the screen are two circuits, and they look identical. But the way that they are powered is completely different. The circuit on top here is one that you are already familiar with. We have three 3-volt LEDs that operate at 20 milliamps each. We are supplying them with 3 volts, and the circuit is drawing 60 milliamps because we've got 3 LEDs that consumes 20 milliamps. Now, the circuit below is controlled in a different manner. Instead of me actually controlling the voltage that is applied to this circuit, I am actually using an active component, so I can adjust the current to the circuit, and the voltage required for the circuit is determined by this active component. So you can see here I have actually set this constant current source to 60 milliamps. So as with the above circuit, where if I add an extra LED, the voltage will stay the same, but the circuit consumes and pulls more current through it because now there is an extra LED in the circuit that is asking for more current. It's pulling more current from the power supply, and sometimes we don't want that. On the below circuit, because this is a current controlled or constant current power source, if I add an extra LED in here, the current actually stays the same, which means the voltage in the entire circuit has dropped. And you can see the LEDs have dimmed, and each of the LEDs are receiving less current because this is a constant current supply, and I have limited the entire circuit to 60 milliamps. So no matter what I do with this circuit, because I'm using a constant current source, the components in the circuit will not be able to draw more current from the power supply. So I now have more control over the current in this circuit. For example, I now want to supply each of these LEDs with 20 milliamps. So all I need to do is change the setting on this constant current source to 80 milliamps, which gives each LED 20 milliamps each, and that's exactly how I want it. I have the control over the current that is supplied in the circuit, and there are so many applications for this. You may have a component or components in a circuit where they are particularly sensitive to current that is applied to them. For example, laser diodes, they are very sensitive to the current applied to them. So if I have a laser diode that requires 150 milliamps, then instead of using a resistor and a voltage source to calculate the current supply to it, it's actually much easier and safer to use a constant current source, because I can then set that constant current source to the required current for that specific device in order to ensure that I'm always supplying the same amount of current, and therefore reducing any possibility of damaging the component in the circuit, because the constant current source will adjust for any anomalies in the power supply to ensure that the current does not go over what I have specified. And that's how constant current sources are different to your standard voltage source. So thank you again for watching. There are many more videos to come, but please do leave your comments below If you have any questions, give the video a thumbs up and subscribe for more.